Hi everyone, this video is on the challenge question of mixed exercise 9, and in this video I'm going to do part E. I've done parts A to D in my previous videos in case you want to watch them. So in part E we want to sketch the curve C finally, after doing lots of calculation, because this challenge question is not hard by any means. It's just that it's very long, and in part E we want to sketch C. But obviously, as you can see, this is we have parametric equations. So sketching this is not something that we can just, do by just looking at these functions for x and y. But what we can do instead is that we can, because the thing is that the main goal of the question was just actually sketching x and y to begin with. But the question simplified that for us by just breaking down the question into a smaller parts, and all of these parts from A to D are basically the first few steps of actually sketching, because we needed to do these steps regardless of the question, if we wanted to sketch the graph. And in this case, so we have done them, and that's good, because if you want to sketch this graph, we need to have the stationary points, we need to have the x intercepts and y intercepts and so on. And actually we do have them right now, because in part B we found the stationary points. So the four stationary points are these ones that I have written in green, and we are going to plot each of these points on the graph. And then in part C we found the x and y intercepts. So these are basically the values of the y-intercept. Actually we only have one y-intercept, so because the y-intercept is just one, and then these are the values of the x-intercepts. So we have four x-intercepts, and then finally in part D we found the value of dx by dy is equal to 0, because this is going to be useful as well. So the difference is that the points that you are going to find, or just the stationary points when divided by this is equal to 0, these are the points that give you the coordinate where the tangent is horizontal. So if you have something like this, this is the part that the tangent is horizontal, and this is give you the coordinates of that, for instance. But the thing is that in part D we have done dx by dy is equal to 0, and the way that that's going to be useful is where you have you have another curve, something like this, and the part that the tangent is like vertical, that's where dx by dy is going to be useful. So in a sense, having dx by dy is equal to 0 is not mandatory in any way, because at least in this question we can still do that without having dx by dy is equal to 0. But since you have found that, we can just use that in our diagram. Okay, so now let's just go and plot each of these points. So this part is just basically all about plotting, because we have done all the hard steps in the previous parts. So we can first begin by sketching by plotting the x and y y-intercepts. So as we discussed, the y-intercept is just 1, so that's the first thing we can do. So the y-intercept is here, it's just 1. Okay, now we can plot the x-intercepts. So we have basically 4 x-intercepts. So one of them is 4.83. Let's say it's here. So 4.83. And then the other one is 1.29. So let's say that's here. 1.29. And then we have minus 1.29, then minus 4.83. So minus 1.29 and then minus 4.83. Okay, these are the x and y intercepts of this curve. Now for the next step, we can plot the stationary points, or where divided by dx is equal to 0. So again, we have 4 points for that, so the green ones. we can start by 5/2 and then 2. So that's almost like here, roughly here. Okay, then the next one we have is basically minus 5/2 and 2. So it's going to be somewhere here. Okay, and then the next one is, let's do the positive one first. 5√3/2 and then minus 2. So let's see what is 5√3 approximately. 5. So using calculator for this one, 5√3 then divided by 2. Okay, so this is approximately 4.3, which means that's here. And then since that's minus 2, here is, let's say, is minus 2. So yeah, it's just something somewhere like here. Okay, yeah, it's very close to 4.83. Then the next coordinate, which is the last one, by the way, is when both of them are negative. So minus 5√3/2 and then minus 2. And that's around here. Okay. Now we need one more. Actually, we can have 2 more points right now, because the thing is that also these are all the x-intercepts, so I can just put a dot here, because ultimately we are going to match all of these. So it's better to have dots. All right, and then finally, yeah, as we discussed earlier, in part D, we found dx by dy is equal to 0, or basically where the tangent is vertical. So we can also use those as well. And then in part D, we had 2 coordinates, basically. So one was -5, -1. So here is -1. And then it's here, it's very close. And then the other one was, which is the last one, is 5 and -1 this time. So that one is here. All right, at this point we have all the points that we need, and now it's all about matching this. So we can start from here, go like this. Sorry that it's not super accurate. Then it then goes to the y-intercept, and from the y-intercept it goes to the x-intercept, and then to the stationary point. I mean, it's not a straight line. It has to be a curve. So yeah, it's very hard to properly draw that here. This is a rough sketch, by the way. You can just go and use Desmos to to look at the accurate one. So then it goes here, and then obviously here, and continues here. Then it returns to the y-intercept, and I will continue, but just to remind you why that happens is because if you remember, the y-intercept repeats twice, so that's why the curve, because that intercepts that twice. Then it goes to this x-intercept, and then finally just goes back to here. So yeah, which is an interesting shape, but obviously this requires a lot of calculations, and it's probably not a very common exam question, but still it's worth knowing how to handle this. All right, that's it for this video, and thank you for watching.